So our goal with Gaussian-Jordan elimination with a 3x3 augmented matrix is to get an identity matrix here, and then whatever numbers here will be our solution.
Hey, be nice.
So first of all, if we want to get a 1 in the top left-hand corner, when writing these equations, I would actually start by writing the third one here first. 1, -2, -1, 2. And then the other ones don't matter so much, so I'll go 2, -1, 2, 10, and 4, 1, 1, 5. As far as ordering goes, we will get those two ones first. I mean those two zeros first, followed by that 0, these two zeros, and then that 0. And part of the way through it, you will also get values of 1s along the diagonal. Now we've already got our 1 on the diagonal in the top left-hand corner.
Wait, are you telling me that if you focus against those zeros every single time, only the other ones?
Yeah, well, they won't equal 1. You might have to do an operation like if it's a 5 there, just divide everything in that row by 5. But that is the ordering that you would need to do, because what this would allow you to do, well, we'll see. We'll see why that order works out the best. So first of all, if I want to get those in column number 1 to be 0, I'm going to have to change row 2. How am I going to change row 2? I'm going to take row 2 and subtract 2 row 1s. And I'm going to take row 3 and I'll make row 3 subtract 4 row 1s. Yes, take some scrap paper, take a bunch. You're going to need it today.
You give me 5. Yeah, you just gotta work it all and we'll share it.
1, -2, -1, 2. So row 1 is not changing here. But if I take row 2 and subtract 2 row 1s, that will give me a 0 here. -1 minus 4, -5, and 2 minus a negative, oops. Oh, hey, did you see what I did?
No.
Oh, you were getting scrap paper. I already made mental math error number 1 by accident on second calculation. So let's see what I did wrong. Okay? And this can happen with subtracting it, especially negatives. If I have -1, row 2, minus 2 row 1s, minus 2 negative 2s is actually adding 4. -1 plus 4 would be 3. Not -5. The next one's going to be 2 plus 2, 4. And the last one, 10 minus 4, 6. Row 3,
Where are you getting the minus 4 from?
because it's row 2 minus 2 of row 1.
Oh, I see. Got it. Yes.
So you double row 1 and then make it negative. And row 3 will be row 3 minus 4 row 1, so this will be 0. Okay? 1 plus 4, this will be 5. 1 minus 8, -7. And 5 minus 40, -35. Are we good?
Yes, we are.
Why is it negative 35? Because we would take 5, row 3, minus 4, row 1s. Oh, I took row 2. And I did that for number, wow, look at that. 2 mental math errors and the one before it. Yeah, okay, here we go. That's all bad. All those numbers. Just seeing if you guys are paying attention. Yes, so we have to take row 3 minus 4 row 1s. This should be 9. And 1 plus 4, this should be 5. And then 5 minus 8, negative 3. That's better? Okay. Excellent. So we have succeeded in getting those to be zeros.
It would have been all right if you wanted to just work on the first zeros and the other zero. Those 2 zeros, as long as you got those 2 first.
We have to get those 2 first.
If you got those 2 first, it doesn't matter if you were working one then the other and not working on them simultaneously.
I did them simultaneously because you could do them separately, but it makes sense to do them together.
Yeah.
Okay? Next, we want to get this to be a 0. So I want to change row 3. Can you see that I can make that 0 by taking row 3 and subtracting 3 row 2s? And I have to use row 2 because that will maintain the zeros in that first column. So again, we haven't changed anything to row 1. In this case, we're not changing anything to row 2. And row 3 is now going to be 0. 5 minus 12, negative 7. And negative 3 minus 18, negative 21. And I'll circle that in green to match up with my color coding above. That was the second goal. At this point, before I get my next zeros, you know how it was easier to get these 2 zeros because we had a 1 in the top left-hand corner? Can you see I can make a 1 in my bottom right-hand corner now? I can take row 3 and make it equal to row 3 divided by negative 7.
You've not just done row
Divided by negative 7 is the same as multiplying by 1 over negative 7. So this is not changing. 2, negative 1, 2. This one's not changing. Yes?
Can you do multiple operations in one?
You can do multiple operations in one. But in this case, that's the only thing I want to do. And I couldn't have done 2 things to row 3 at the same time because it's too many calculations on one row. So as far as showing your work, you could change row 2 and row 1 in this same one if you had stuff to work with. That's fine. And you notice I did 2 operations in the first one. I'm going to do 2 operations in this next one because now, as far as color coding, I'm on to the black and I can get both of those zeros in the same step. So row 1, it can equal row 1 plus row 3, and row 2, it can equal row 2 minus 4 row 3s. So what haven't I changed? I haven't changed row 3. Row 1 is row 1 plus row 3. Well, math is getting easier now because there's a whole bunch of zeros. And 1 plus negative 1, that'll be 0. And 3 plus 2 will be 5.
Should be negative, yeah.
What should, oh yeah, look at that.
Weird, Mr. Roth. Is this a good day for you?
It's not a good day for me. And then row 2, if we minus 4 row 3's, well, this will still be 0. This will still be 3. This will be 0 now. And 6 minus 12.
Wait, explain how is that 3? How is multiplying 4 row 3? What's that?
Well, I'm multiplying row 3 by 4, so this 0 gets multiplied by 4.
Oh, I see. Got it. Oh, I got it now.
And so now we've succeeded in this step of getting those two to be zeros. At this point, can you see that you can make that middle number a 1? So I'll take row 2, and I'll take row 2 and divide it by 3. And now we can do our final step here. Take row 1 and add 2 row 2's. Row 1 and 2, row 2 and 3 won't change. 2 row 2's, that will keep this a 1, make this a 0. Make this a 0, and make that a 1. We've succeeded in getting this to be 0, and because we already had a 1 in the top left-hand corner, we are done. We know at this point that x is equal to 1, y is equal to negative 2, and z is equal to 3.
Obviously, if you did the zeros where you put the top left-hand corner of zeros and the bottom right-hand corner of zeros, you get.
Yeah, if you wanted to work, you would
still work,
you would just starting at the, you'd just be flipping things around.
Alright, that's it.
Yeah.
Got it. So it would work if
It would work. It just, this is,
you want to teach it the standard way.
yeah,
Got it.
that would work. What doesn't work is if you try to get, you know, the one that I circled in green or purple, if you try to get that one first, and then try to get the other ones, you're going to run into problems because they're going to get undone. What we need is these 2 black zeros allowed us to go from row 2 to row 1 without affecting that 0.
Yeah, that's important.
So what we're going to do for this next one, okay?
Let's do it.
It has nice numbers as answers. Find a partner, okay? I want you to find a partner and decide on the same row operations at the same time, but do it individually. And then before you go on to the next step, you can look at each other and say, did we get the same numbers?
That's going fun, right?
Right? As opposed to doing it all on your own, making a mental math error, which I hoped in the first example I demonstrated how easy it is to do.
On purpose.
Oh, definitely not on purpose. No. But I did all of the, this is what I did for this one. First of all, I wrote equation 2 first to get a 1 in the top left-hand corner. Then I succeeded in getting both of those zeros. Sometimes doing a little step along the way can make your life easier. So to get these 2 numbers the same, I multiplied row 2 by 3 and row 3 by 4. That made both of those 48s. And it just made some calculations a little bit easier because now that they're both 48s, I can just subtract them. That gets this second 0 and all my zeros in the bottom left-hand corner. I can now divide row 3 by 17 to get that to be a 1, and we already know that z is equal to -3. In Gaussian elimination, we would be done and now just substitute back all the way through to figure out the other values. Next, I'm going to get both of these to be zeros, so I got the row 2 to be 0 first. And once that row 2 is 0, I divided by 16 to get it 1, and then I got row 1 to be 0 as well. We could have done this step here at the same time as this one. In fact, if I were to do this again, I probably would have done those two at the same time and got both of those zeros at once. Finally, we can get that last 0 and get the solution. I can scroll up again, yep. Whoops, that's paging up. Here we go. Where would you like to see?